friends, welcome to the series lecture of Mathematics 1. In the last session, we have seen topics up to power series. In a power series, you can apply any test like as ratio or root. You have seen the power series for x greater than 0. Today, we are going to discuss the power series on whole of the real line, and you can have any value negative as well as positive. Using that, we are going to define two topics. First one is the radius of convergence, second one is the interval of convergence. Now for that, what you have to do, suppose sigma un is any power series where n is running from 0 to infinity an into x minus a raised to n. Then we are either starting with a root test or a ratio test. You can use either of them. Now since we are not aware of what is the value of an or what is the value of x minus a, either it is positive or it is negative. So these two tests are applicable for only and only positive term series. That's why we are starting with the mode of them. So that's why we are starting with a un plus 1 is an plus 1 x minus a raised to an plus 1, and we are going to find the limit of mode of un plus 1 upon un. If you are not writing mode, then you cannot define what is the exact condition for convergence or divergence. That's why we have introduced the mode. So mode of un plus 1 upon un, if you are going to put the values and simplifying, then you will have mode of an plus 1 upon an into x minus a. Now x minus a is a constant with respect to the limit, so it can be common out from the limit. So you have mode of x minus a into the limit mode of an plus 1 upon an. Now suppose this limit has a value something capital L. That means the limit of un plus 1 upon un is going to be mode of x minus a into L. Now we are going to use the condition of ratio test, because we have applied the ratio test, and you are already aware of for mode whatever the answer is less than 1, then your series is convergent. That means mode of x minus a into L is less than 1, that is x minus a is mode of x minus a is less than 1 upon capital L, then the series is convergent. And if mode of x minus a into L is greater than 1, that means mode of x minus a is greater than 1 upon L, capital L, that then your series is divergent. And whenever it is equal to 1, then your test fails. Test fails, in that case you have to apply some another test. So please remember, at that time we are going to apply some another test. Here note that 1 upon L is called the radius of convergence. That means whatever the value you get for mode x minus a is less than whatever, that whatever is your capital R, it is called the radius of convergence, and it is denoted by capital R. Now we are going with a series. Suppose sigma an into x minus a raised to n is a series. Then there are three possibilities. Either your series converges for all x, that means your ROC, radius of convergence, is infinite. Secondly, it is only convergent for x is equal to a, that means it is convergent for only given center x is equal to a if radius is 0. And third case we have already discussed, if r is any positive real number, then mode of x minus a is less than r, then your series is convergent, and for mode of x minus a greater than r, your series is divergent. Now using the condition C, we are going to third condition, we are going to simplify it, and if you are writing mode of x minus a is less than r in a simple form, that means if you are going to eliminate the mode, then you will have minus capital R is less than x minus a is less than capital R. Adding a both side, that will give you a minus capital R is less than x is less than a plus capital R. So whatever this interval you have, a minus capital R to a plus capital R, this interval is called the area of convergence. That means if the axis lies between these two values, then your series is convergent. So this interval is called the interval of convergence. Now at the end point a plus or minus r, your series may be convergent or may be divergent. So according to the convergent and divergent, there are four possibilities. Either the left hand, that means a minus r, both are not included, or right hand side a plus r is included, or left hand side a minus r is included, or both are included. That means at both end point it is convergent, or at one of the end point it is convergent, or it is convergent at neither of end point. But inside that it is always going to be convergent, and this interval is called the interval of convergence. So this is the basic idea. Using this we are going to solve some of the examples. So first example we are going to check out. Find the radius of convergence and interval of convergence for the series sigma n running from 0 to infinity minus 3 raised to n into x raised to n divided by root of n plus 1. So your un is minus 3 raised to n x raised to n upon root of n plus 1, correct? So we are writing un plus 1, that will be minus 3 raised to n plus 1 into x raised to n plus 1 upon root of n plus 2. And applying limit to the mode un plus 1 upon un, and that will, and simplifying that will give you minus 3 raised to n cancel out, 3 x raised to n cancel out, and the remaining terms you will have mode of under root n plus 1 divided by n plus 2 into minus of 3x. But since we have a mode, so minus is going to be eliminated, and 3x is constant with respect to limit, so it will be common out. So you will have mode of 3x, or 3 into mode x. As we are not aware of x is positive or negative, that's why we have to write the mode. And the remaining part is nothing but under root of n plus 1 upon n plus 2. Divide numerator denominator with n and simplify, that will give you the limit has a value 1. So final limit has an answer 3 into mode of x, correct? Now using the condition of convergence, that means if ratio test, if we are applying the condition of ratio test, then it converges for less than 1, that means 3 into mode x is less than 1. That means mode x is less than 1 by 3, then your series is convergent. Then same manner mode x is greater than 1 by 3, then our series is divergent. Now if you are going to eliminate the mode, then you will have interval from minus 1 by 3 is less than x is less than 1 by 3. That means from minus 1 by 3 to plus 1 by 3, our series is convergent. And since you have mode is less than 1 by 3, that means whatever the right hand side we have, that is our radius of convergence. So radius of convergence capital R is equal to 1 by 3, correct? Now at the end point, that means mode x is equal to 1 by 3. That means x is either 1 by 3 or it is minus 1 by 3, correct? So in that case we have to check out. So first we are going to check for x is equal to minus 1 by 3. Suppose x is equal to minus 1 by 3, then we are going to put this value in un. Then un is going to be of the form minus 3 raised to n into minus 1 by 3 raised to n divided by root of n plus 1. Now minus 3 raised to n minus 3 raised to n will be cancelled out, and you will have 1 upon root of n plus 1. That means un is a simple algebraic form. So we are going to apply the comparison test, and for that we are going to take 1 Vn, and Vn is nothing but it is dominant part of numerator and dominant part of denominator, that is nothing but 1 upon root n. Now to apply comparison test, you have to find the limit un upon Vn. So limit of un upon Vn is nothing but limit root n upon root of n plus 1, and simply root n common out from denominator, that will give you 1 upon under root of 1 plus 1 by n. Applying limit, that will be our answer 1. 1 is non-zero finite, so by comparison test this series is either convergent or divergent. It is depending on the values of Vn. Now sigma Vn is a P series, and P series with P is equal to 1 by 2, because 1 upon n root n, that means n raised to 1 by 2. Now for 1 by 2 your P series is divergent. So this series sigma Vn is divergent, and since sigma Vn is divergent, so by comparison test sigma Un is also divergent. That means for x is equal to minus 1 by minus 1 by 3, your series is going to be a divergent. So please remember it. Same manner, now we are going with a x is equal to 1 by 3. So for x is equal to 1 by 3, if you are going to put 1 by 3 in your un, then un is going to be minus 3 raised to n into 1 by 3 raised to n divided by under root of n plus 1. See, 3 raised to n, 3 raised to n will be cancelled out, and you will have minus 1 raised to n remaining in numerator. So now minus 1 raised to n, that means your series is the alternating series, correct? And if you have alternating series, then you have to apply the Leibniz test. For Leibniz test, we are going to consider only and only the positive part, that means mode part of the original series. Minus 1 raised to n is going to be neglected out. So we are starting with mode un and mode un plus 1. So mode un minus mode of un plus 1, that will be a 1 upon under root of n plus 1 minus 1 upon under root of n plus 2. And if you are cross multiply and simplify, then that will have obviously value greater than 0. That means the given series is numerically decreasing. And if you are going to find the limit mode un, that means if you are applying limit to the nth term, then it will be 0. So both conditions of Leibniz test are going to be satisfied, and that's why this series is convergent for x is equal to 1 by 3. So for x is equal to 1 by 3, your series is convergent. X is equal to minus 1 by 3, your series is divergent. So if you are writing the interval of convergence, then minus 1 by 3 less than x less or equal to 1 by 3, your series is going to be convergent, correct? And that's why you have to write down open interval minus 1 by 3 to close interval plus 1 by 3, correct? So that is your interval of convergent, close to open. Then same manner, we are going to check out one more example. Now for the series sigma n running from 1 to infinite, minus 1 raised to n into x plus 2 raised to n divided by n. Find the radius of convergence, and for what values of x does the series converges absolutely and conditionally. Now see, here it is asked absolute and conditional convergence. And as we are already aware of, wherever the mode series is convergent, then your series is said to be absolutely convergent. And if original series is convergent but mode series is divergent, then it is conditionally convergent. So what we are going to check out, we are first going to check out at where your series is convergent and at where your series is divergent. So we are starting with un is equal to minus 1 raised to n into x plus 2 raised to n divided by n. So I am starting with a root test. So un raised to 1 upon n, that will be a minus 1 into x plus 2 divided by nth root of n. Applying limit to the mode of them, because see, if you can apply the root test to the positive term series only, that's why we are applying mode. So limit n tends to infinity, mode of un raised to 1 upon n, that will be mode of minus 1 into x plus 2 divided by nth root of n. Now as you have mode, that means minus is going to be eliminated and the remaining part is mode x plus 2 upon nth root of n. Now mode of x plus 2, we don't know what is the exact value, it is positive or negative, but it is constant. So mode of x plus 2 is common out and the remaining part is mode of 1 upon nth root of n. But nth root of n has a value 1. So the final answer of the limit un raised to 1 upon n is nothing but mode of x plus 2. So using the condition of root test, mode of x plus 2 is less than 1, then your series is convergent, correct? Same manner, mode of x plus 2 is greater than 1, then your series is divergent. And for mode of x plus 2 is equal to 1, your test is going to be fail out. So if you are eliminating mode from the convergence, then mode of x plus 2 less than 1, that means minus 1 less than x plus 2 less than 1, and adding minus 2, then that will give you minus 3 less than x less than minus 1. So that will be your interval of convergence. At the end point, that means at the end point, that means x is equal to minus 3 or x is equal to minus 1, you have to check out whether series is convergent or it is divergent. So if you are going to put x is equal to minus 3, then you will have un is equal to minus 1 raised to n into minus 1 raised to n, because minus 3 plus 2, that will be minus 1. So you will have minus 1 raised to n minus 1 raised to n divided by n, that will be a 1 by n. But sigma 1 upon n is your p series, and p series with p is equal to 1. That's why it is obviously divergent, because p is 1. So sigma un is divergent, that means your series is divergent for x is equal to minus 3. Same manner, now for x is equal to minus 1. If you are going to put x is equal to minus 1, then un will be minus 1 raised to n into minus 1 plus 2, that will be 1 raised to n. 1 raised to n will be 1. So that will give un is minus 1 raised to n upon n. So here it is minus 1 raised to n is there, that means it is a alternating series, and alternating series, that means we are going to apply Leibniz test without considering the sign. So mod un will be 1 upon l, mod un plus 1 will be 1 upon n plus 1, and subtract them and simplify, that will give you 1 upon n into n plus 1, which is obviously greater than 0. And since it is greater than 0, so your series is going to be that means it is numerically decreasing. Now the limit of mod un, that means the limit of 1 upon n will be 0. So both the condition, the series is numerically decreasing, and second one, the limit of nth term must be 0. Both conditions are satisfied. Therefore your series is going to be convergent for x is equal to minus 1. Now see, at minus 1 your series is convergent, at a minus 3 your series is divergent. So if you are writing the area of convergence, then the given series is going to be convergent for minus 3 less than x less than or equal to minus 1. And interval of convergence will be minus 3 less open interval minus 3 to close interval minus 1. Okay. But now we also have to write down the absolute and conditional convergence. So for see, we have proved that for your series is convergent for minus 3 to minus 1, open interval minus 3 to minus 1, and it is absolutely convergent. That's why your series is going to be absolutely convergent for minus 3 to minus 1. But at the end point minus 3 and minus 1, for minus 3 your series is not convergent, it is divergent, and at a minus 1 your series is convergent. So at a minus 1 your series is convergent, but its mode series is divergent, because mode series is going to be 1 upon n, and it is divergent, so it is conditionally convergent. That means from minus 3 to minus 1 your series is absolutely convergent, and at a point x is equal to minus 1 your series is conditionally convergent. Okay. Now at last we are going to start with an example. Find the interval of convergence of x sigma x raised to n upon n factorial. Now see, here un is nothing but it is x raised to n upon n factorial, and since factorial is there, so we are going to use the ratio test. So un plus 1, that will be a x raised to n plus 1 upon n plus 1 factorial. Now we are going to apply the ratio, so we are going to find the limit n tends to infinity mod of un plus 1 upon un. So putting the values of un plus 1 and un, that will give you limit n tends to infinity mod of x raised to n plus 1 upon n plus 1 factorial into n factorial upon x raised to n. X raised to n, x raised to n will be cancelled out, and n plus 1 factorial can be separated by n plus 1 into n factorial. Then n factorial is also going to be cancelled out, and you will have the remaining term as x upon n plus 1. Now x is constant with respect to the limit, so what we are going to do, we are going to common out x, so mod x will be common out, and we will have limit n tends to infinity 1 upon n plus 1. Now as n tends to infinity, 1 upon n plus 1 tends to 0, and that will give you 1 upon mod x into 0, that will be a 0. So now see, what is your limit that is not depending on the values of x. That's why you have a value 0 and it is less than 1. So if you are applying the ratio test, then your series is convergent for any values of x. That means your ROC, radius of convergence, is infinity. So this is the basic concepts of power series. If you have any doubts or any query regarding this topic, then please feel free to contact me. Thank you.